So I had problem number 17, which says find the number of consecutive zeros at the end of the product 1 factorial times 2 factorial times 3 factorial up to 115 factorial. So we're going to have to look at the prime factorization of this number, just like we did in another problem that's similar to this. Say if we just find the number of zeros at the end of 115 factorial. So if we look at the prime factorization of 115, and we look at the power of 5 and the power of 2, that's going to give us how many times 10 goes into the number, which is going to give us how many zeros are at the end of the product. So, and there's going to be a lot more 2's that go into this number than 5's in the prime factorization. So really we just need to look at 5's. So first we're going to have to do 115 divided by 5, and that's 23. And then we're also going to have to do 115 divided by 25, because that gives us an extra 5 in the prime factorization, and that's going to be 4. So there's going to be 27 zeros at the end of 115 factorial. So we're going to have to do that for every number from 1 to 115. So that might sound difficult, but there's going to be a pattern that we'll see, and then it'll make it a lot easier. So if we look at 115, we saw that 5 goes into that 23 times. And then if we look at 114, we know that 5 goes into that 22 times. Same thing with 113, all the way down to 110. And then 109, there's 21 5's. And that's going to be the same thing all the way down to 105. And then 104 is 25's, all the way down to 100. So hopefully you can see the pattern here. There's going to be between 114 and 110, there's going to be 5 times 22 5's in the prime factorization. 109 to 105 is also 5. So you have groups of 5 that you're going to have to multiply by these numbers to get the number of zeros at the end. And you're going to have to do the same thing with dividing by 25. So you have 115 divided by 25 is 4. Same thing with 114 all the way down to 100. And then 99 is 3 all the way down to 75. So here you have 16 from 100 to 115. But then here you have 25, and then this is also 25. So there's also a pattern there. So you need to add all of these numbers up to get the number of 5's that are in this big number. So let's just do that here. So you have 23 is at the top, plus 5 times 22, plus 5 times 21, all the way down to 5 times 1. And then you're going to have 16 times 4, plus 25 times 3, plus 25 times 2, plus 25 times 1. So let's just rewrite that as 23 plus 5. I just took the 5 out of here, and then I'm just going to switch it like 1 plus 2 plus 3. All the way up to 22. So I just factored out a 5 in between from here to here. Plus 16 times 4. I'm going to do the same thing here. Factor out 25. And then to get 1 plus 2 plus 3 all the way up to 22, there's a formula that goes 1 plus 2 plus 3 plus up to n is going to be n plus 1 times n over 2. So 1 plus 2 plus 3 all the way up to 22 is going to be 23 times 22 over 2, or 23 times 11. So this is 5 times 23 times 11, plus 16 times 4 is 64, and then 1 plus 2 plus 3 is 6, so it's 25 times 6. And then once you multiply all this out and add it all together, you're going to get 1,502. And that is going to be how many 5s go into this number, and then that's also going to tell you how many zeros are at the end of that product. Thank you.